Okay, so let's get started. We're going to be taking a look at setting up and working with our paddle shift type control within our Link G5 and G4X programming. Now, our paddle shift is definitely probably the most complex control strategy we have to work with within our Link programming. So this tutorial is going to be a little bit on the long side. We want to cover as much of this control strategy as possible. There are a ton of different inputs and outputs that we have to configure, and then we have to understand the settings and what they actually do in this control strategy. When we're talking about a paddle shift option, we're controlling a sequential gearbox with a shift actuator to shift up or down when we're requesting the shift to happen off of our paddles, but it's also going to be working with air pressure, airline pressure. It has to have a certain amount of pressure which we're going to be working with to get the shift actuator to move, and we're controlling a air compressor pump to generate the line pressure and being able to keep that consistent for the shifting. So we have a ton of different things to configure again, and we're going to try to go over every little detail here for the paddle shift option. So let's jump in. Let's talk about where we can find the page that we're going to be doing our programming for the paddle shift. And then we're going to take a look at a schematic that's going to go over all of the components in our control system. We'll talk about each individual aspect here, and we're going to move into configuring then the inputs and outputs first. Then we're going to talk about our control strategy and programming next and try to break this down again as thoroughly as possible. There is a ton of things to cover here, so it might get a little bit overwhelming. Let's jump in here and let's take a look at the page first and get started. We're going to move from our fuel page here. We're going to look for our page label paddle shift. We're going to go to layout, and we're going to jump down here and we see paddle shift option. Now this page looks super overwhelming if you're taking a look at it. There are a ton of tables to work with for this control strategy. So again, we're going to try to keep this as simple as possible. One thing to keep in mind with this page, and one thing I was kind of a little bit annoyed with as I was going through and setting up everything for the gear shift control and just making sure that I had everything in order here for the tutorial, is the way that Link structures the table. For example, when we're taking a look here, we have dog unload duration. If we take a look, we also have dog unload duration. There's an upshift and a downshift dog unload duration. So what Link doesn't do is put in the naming upshift or downshift. So this can get confusing. So the way I've set up my layout here to try to keep this as simple as possible, the left side is things related to upshifting. The right side is things related to downshifting. That way, when we're enabling and turning everything on here and we have all these various tables, we know when we're editing a table, if it's an upshift table or a downshift table. Now, things may change in the software and they might put that into the naming, but at this point in time, that doesn't exist, so it can get a bit confusing. Okay, so I just wanted to get that out of the way first. All right, so what we're going to do right now is take a look here at our schematic and the various components that we have to assign, configure, and work with here in our control strategy for paddle shifting. So coming up on screen, we're going to find our schematic. The very first thing is we find our Link G5 in this example. Then we find our paddles. The paddles are going to be mounted to the steering wheel, typically. The paddles are going to have an upshift request and a downshift request. So typically, the right paddle will be upshift, the left paddle will be downshift. Now the paddles are simple switch circuits. In my particular example here, I'm going to have a ground wire that's going to be grounding the circuits for either the up or the downshift paddles. And when I actually hit the paddle, so I actuate it on the up or actuate it on the down, that will be then sending a ground input to one of my two digital inputs that I've assigned here. So I have a digital 3 assigned for an upshift, digital 4 assigned for a downshift paddle request. And again, I have a common ground going into each switch circuit. And when I hit the paddle, then I'm grounding either digital 3 for upshift, or if I'm grabbing the downshift paddle, it's grounding digital 4. That way the Link knows I'm requesting an up or a downshift. Simple enough there. The next few things we have here in our control strategy, we see we have our sequential gearbox. Then we also find in the sequential gearbox a gear barrel position sensor. When we're shifting the lever on our sequential gearbox, that will then move the barrel sensor, or the barrel position, which has a sensor assigned to it. That sensor is going to be sending a 0 to 5 volt output from the sensor. depending on our position that we're at. My gearbox is going reverse, then neutral, first, second, third, fourth, fifth, sixth. I have a distinct voltage assigned to each gear position. That's how the control strategy is going to be basing everything around here. So we're integrating a gear barrel position sensor, which is going to give accurate gear detection, but we need to wire in an analog input for the gear barrel position sensor. So that's an input that we have to wire in. So we have our 2 digital inputs for the paddle up and down shift request. Now we're going to have an analog input, 0 to 5 volt input for the gear barrel position sensor. That's going to be coming in on my wiring here to analog input 4. The next thing we can find here is that there's going to be a shift actuator, which is going to be controlling the up and down shift requests. So when we actuate the paddles on an upshift or a downshift, that's going to be moving the shift actuator to move the shifter up or down depending on up or downshift request. So we're directly controlling the shift actuator or actuators. Typically, we're going to find the shift actuator is going to have 2 control wires that we're going to be working with. And you may have dual shift actuators depending on the shift actuator and the transmission. But we'll find we typically have an upshift request actuator and a downshift request actuator to move the actuator in the forward or the backwards position to move that gear lever up or down to make that shift request happen, shifting up or down. So we have 2 control wires that are going to be controlling our shift actuator. We're going to be assigning those to either ignition output, injector output, or an aux output. And we'll assign those here as we go through. Now, the next thing here is going to be the shift actuator is fed with air pressure. So we find that we have an air tank, and we're going to have a line going from the air tank to the shift actuator. Then we're going to have a air compressor pump that's going to be generating constant air pressure into the tank. So the system holds and controls at a constant pressure. Very important because the shift actuator needs a minimum pressure to actually operate. So we have to have a closed loop system here, turning the pump on when it's needed and then turning the pump off when it's not needed. Now, in order to make this work, we're going to have a bottle pressure sensor or a line pressure sensor. So it's going to be actually measuring how much pressure we have in the line going to the shift actuator. Very important that that's going to be above the minimum. Depending on what type of shift actuator you're working with, the minimum pressure is going to vary. So you have to go to the manufacturer of the system for the shift actuator and find out what the minimum pressure the system needs to operate at, and always try to keep yourself above that. Now, we can do this in the closed loop strategy with our paddle shift, and we're going to talk about how to do that. But the pressure sensor is something that we do have to have wired in here to the link, which is going to require another analog voltage input, which I have assigned to analog voltage 3. Now, we're also trying to control the air compressor pump to make sure that we always have that constant air pressure. The air compressor pump will be controlled through a relay because we can't directly control and drive an air compressor pump. It pulls too much amperage. So we're using a relay to handle the switching load. I have a basic 30-40 amp relay. We're going to be controlling it in an on and off fashion, and we're going to be low side grounding that relay. So pretty simple there. So looking at this, we have our various different components in our system. We know in this case that we have to wire in a paddle up and paddle down shift request, a gear barrel position sensor, air pressure sensor, and we also have some outputs. We have our shift actuator, typically 2 outputs to control up and down shift request, and then we have an output to control our air pressure AC compressor pump. Not AC pressure, air pressure pump. Okay, so now we've talked about all the various components in our system. Let's jump in here and take a look at setting everything up here. So we're going to go to our start shift mode, and we're going to go from off, and we're going to choose digital paddle shift. Let's go ahead and click OK here. Now, when we do that, we find a ton of different programming options start to appear here. Don't panic. We're going to go through all of these one by one. So the first thing I want to do here is go through and just start setting up our inputs. 2 digital inputs, 1 assigned for upshift, 1 assigned for downshift from our paddles. That's going to be found here under gear shift inputs. Upshift digital input, in my case, is going to be assigned to digital input 3. Again, I'm sending a ground into the circuit, and when I actuate the up or downshift paddle, it'll then be grounding the input that we're wiring them into. So I need the pull-up resistor on, and I need the active state as low. If I was sending a 12 volt in, we would have pull-up resistor off, active state as high. Simple enough. Let's go to our downshift digital input. We're going to be setting this to digital input 4 here, and again, pull-up resistor on and active state low. Now, neither of these I want to set up as a input latching function. When we hit the paddle and we let go, we want that ground to drop off of our digital inputs. So very important we're not setting this under a latch. Next thing we're going to do here, let's go down here a little bit. Let's go and assign all the way down to the bottom here under compressor control. Let's assign the analog input for the pressure sensor. So we're going to go to our pressure source, and then I'm going to go and assign this, in my particular case, to analog voltage 3. Now there's a low and a high error here. We can keep this at 0 and 5 volt for the time being, but let's go.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.